All right, so we are going to be starting assignment number 8 today. And we'll be getting into things like permutations and combinations and factorials. But before we start today, we are going to start with a pop quiz. And so 4 questions. The first one is either true or false. And so okay, the first one is either going to be true or false. The second one would be true or false. The third one would be a multiple choice, either A, B, C, or D. And the fourth one would be either A, B, C, or D. And suppose you were to guess, okay, how many ways could you answer the first 4 questions? Like, for example, it could be true, false, A, C, or false, true, B, B. How many different ways are there to answer that question? Well, here we have 2 choices, here we have 2 choices, here we have 4 choices, and here we have 4 choices. The correct answer to the question is going to be 64 ways. Well, how did we get that? Well, question number 1 had 2 choices, so it could be either true or false. Question number 2 had 2 choices, so far I'm at true, true, or true, false, false, true, or false, false. And I had 2 choices here and 2 choices here. 2 times 2 is 4. Well, my third question had 4 choices. 1, 2, 3, 4 here. 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 Well, that's 4 sets of 4. So that's going to be a total of 16 different choices. And one way to get that is to take 2 times 2 times 4. Well, then my fourth question had 4 more choices. So off of each of those 16 different choices, I'm going to have 4 more choices. So it's going to be 16 times 4 more, which is 64 different possibilities. What I want you to see here is that if I have a bunch of different choices for answering the questions, I just multiply those choices together, and that tells me how many ways there are to answer that question. That leads us to the basic counting rule. Okay, if there are R actions to be performed in a definite order, and there are M possibilities for each of those actions, then I would just take M1 times M2 all the way up to MR. So for example, we had 2 choices, and then 2 choices, and then 4 choices, and then 4 choices, and I'm just multiplying them together. What we just went over is called the basic counting rule. So that leads us to some more examples. Let's take a look at this one. How many dinners are possible if you have 3 choices for a main dish, 4 choices for a side, 2 choices for salads, and 3 choices for desserts? Well, like one choice might be I want the steak, I want the mashed potatoes, I want a garden salad, and I want a sugar cream pie for dessert. That would be one of those choices. But I had 3 choices for the main dish, 4 choices for the side, 2 choices for a salad, and 3 choices for dessert. So if I multiply all those together, 3 times 4 is 12, 12 times 2 is 24, 24 times 3, that's 72 different meals are possible. And that's example number 2. Here's another example. How many orders are possible if you want to arrange your 5 favorite love songs on a playlist? So suppose you're going to give a CD to that special someone in your life, and you have 5 of your favorite love songs that you want to put on this CD. Well, how many choices do you have for the first love song? Well, there's 5 choices. Once you pick the first one, then how many choices do you have left for the fourth one? Or for the second one? And that's 4 choices. Then I'm going to have 3 choices left. Then I'll have 2 choices left, and then finally, my last one would be in the last spot. Well, I'd multiply those together just like I would multiply my number of choices of types of food together. And if I took 5 times 4, that's 20. 20 times 3 is 60. 60 times 2 is 120. That's going to be 120 different arrangements. Well, another way that you could do that same problem is to do 5 factorial. 5 factorial means that you take that number 5 and you multiply it times 4 times 3 times 2 times 1. And if you go to your calculator, you can do this on your calculator as well. You have to start by pressing 5, and then press the math button and go over to prob, and then go down to factorial, and you'll see that 5 factorial is 120. I want you to do that on your calculator. Now I'll repeat that again. You go press 5 first, then you press the math button, which is right underneath the alpha button. And when you press the math button, over to the right, you'll see a PROB, prob. You press that button, and then the fourth thing that you can choose is the factorial sign. And 5 factorial is 120. That's what you can do whenever the numbers are in descending order like they are here. So here's factorials. The product of the first k numbers would be considered k factorial. So if I wanted to find 8 times 7 times 6 times 5 all the way down, that would be 8 factorial. Okay, and that's what k factorial means. So we're going to be using that a lot throughout this lesson as we continue. Oh, and one thing, 0 factorial, that is just a special rule. 0 factorial is just 1. Okay, that's the way we would define it because it completes a pattern. It's like anything to the 0 power is 1. All right, so let's take a look at example 4. We're going to be adding something new here, but let's start off with factorials. How many orders are possible if you only have room for 3 of your favorite 5 love songs on your playlist? Okay, so I'm only going to send her 3 of my 5 favorite songs. I still have 5 songs to choose from for my first song, and then 4 for my second, and then 3 for my third. And I can multiply those together. 5 times 4 is 20, and 20 times 3 is 60. So the answer to this question is 60, but let's talk about different ways of doing this problem. I could do this. I could take 5 factorial divided by 2 factorial. Now you're asking, why in the world would that work? Well, first of all, 5 factorial means 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. So the 2 and the 1 would cancel, and I'm left with 5 times 4 times 3, which is what I have up here. Okay, so I could do it that way on my calculator, but there's a special button for doing that on your calculator. This is called a permutation. And if you go to your calculator, it is an NPR button. And the way this would work is this. The N, we have 5 songs to choose from. It's a permutation because the order that I'm putting them in will matter, and I'm picking 3 of them. Okay? To put this into my calculator, I'm going to start by pressing the 5. Okay? So go back to your regular mode, press 5, and then go to your math button, go over to PRB, and you can see the second thing down is NPR. So if you press that, then it'll have the 5P, and then you'll have to press the 3, and that gives you 60. This is a permutation because I want to select a certain number out of a bigger number, and I want to put those numbers in a particular order, and that's called a permutation. Okay, so these would be the 60 different possibilities. You can see we have 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 times 10 is 60. That's the 60 possibilities all listed out. Okay, but we can do that just by using our formula. We wouldn't have to list them all out like it is in this sample space. Okay, so here we have a permutation. MPR on our calculators, it's NPR. Okay, just replace the N with an M. Okay, but what that means is this. This is the exact same thing as taking N factorial divided by N minus R. N minus R factorial. And that worked in our last example because we had N was 5 and I was picking 3 of them. And we said this was the same thing as taking 5 factorial divided by 5 minus 3, which is 2 factorial. Okay, you really won't need to know that. You just need to know that it's a permutation, and this button on your calculator will help you solve those questions. So let's take a look at a different situation. It says the number of possible permutations of M objects among themselves is M factorial. So for example, this goes back to the second example that we did. If I'm picking 5 songs out of 5, okay, well, I could do this by going 5P5. Okay, but that's just the same thing as 5 factorial. And you can try that on your calculator. If you press 5 and then go to math, go to PRB, go down to number 2, and make it 5, picking 5, that's 120. But also if I do 5 factorial, that's 120. Okay? So permutations are really just a special case of factorials are just a special case of permutations where these two numbers match. Let's get into something that's not a permutation, but a lot of people mistake it for a permutation. Okay? Suppose you want to select 3 of your 5 friends to travel with you to spring break. So how many groups of 3 are possible? Okay, so you're going to pick 3. Let's say you have 5 really close friends, but your parents say you can only take 3. Well, you can pick Al, Bill, and Dan, or Al, Chris, and Evan, or Al, Bill, and Chris. But you have 5 people to choose from first. Once you pick one friend that's going to go with you, then you'll have 4 friends to go next, and then you'll have 3 friends for last. And we already said that that is 60. Here's the problem. If I pick Al and Bill and Chris, and later on I say, no, I want to take Bill and Chris and Al. Those are the same 3 people because order doesn't matter. It's not like the song list where the order that you had those songs in was a different order, so we counted it differently. Well, if I have those 3 people, how many different ways can I order Al, Bill, and Chris? Well, to order Al, Bill, and Chris, I have 3 people that could be first. Once I pick the first person, I have 2 that could be second. And once I pick the second person, I have 1 that could be third. Well, that's 3 factorial, or 3 times 2 times 1. 3 times 2 times 1 is just 6, which means that group of 3 people is counted in here 6 different times. As a matter of fact, every group is counted in here 6 different times. So what I'm going to have to do is divide 60 by 6, giving me only 10 possible groups of 5 where order doesn't matter. Well, this is another way that I could have done this problem is by doing this. I could have done 5 factorial divided by 2 factorial. That gives me the 60 like we did on the last page. And then I want to divide that by 3 factorial, which is what I did up here. Okay? I could do that on my calculator, but there's also a special button for that as well. And that is the button that looks like this, NCR. The C stands for a combination. A combination is when order doesn't matter. The way this particular problem would look, I'm picking from 5 people. I don't care about their order, but I'm picking 3 of those 5 people. And so I'm going to do that on my calculator. I'm going to start with 5. I'm going to go to math. I'm going to go over to probability and go down to NCR. And then I will put in 3 because I'm picking 3 of those people, and that gives me 10. I have 10 groups of 5 where order doesn't matter. And so that's called a combination. So a combination has a formula that looks like this, where again, you're not going to need to know this formula. What you're going to need to know is just that it's a combination. But the way that it worked in our last example, I had 5 people to choose from, and I'm picking 3. And that's 5 factorial. That's what the M is. Those are the same. I'm going to divide that by R, which is 3 factorial, and then times M minus R, which is 2 factorial. Okay? And that's what we had here. Okay, but you don't really need to know that. I'm not going to make you memorize that formula. I just want you to know that the button on your calculator will give you the answer to those combinations. Let's take a look at this example. It says it's the number of possible, or a special combination. The number of possible samples of size n from a population of size n is NCN. So this is what we just talked about. We just called it NCR. Okay? And you'll need to use your calculator to answer those questions. Here's an example of that. How many starting lineups are possible for a basketball team with 12 different players? So the first thing I need to know is this a permutation or a combination? Well, on a basketball team, it doesn't matter. I have 5 people that are going to start, but it doesn't matter who I pick first. The 5, it's a group of 5, so order doesn't matter. So this is going to be a combination. I have 12 people to choose from, and I want to pick 5 of them. So this is going to be 12 combination where I'm picking 5. And so on my calculator, I'd start by entering 12, go over to probability, go down to NCR, put in 5, and that's going to be 792 different starting lineups. Okay? That question is a little bit different than this one. How many starting batting lineups are possible on a baseball team with 12 different players? Okay, so here I have a starting lineup. Does it matter who bats first and second and third? Here the order matters. It's a batting lineup. It's not just a group of 9 players that are going to play. Okay? It's a group of 9 players that are going to make up my batting lineup. It's 9 because that's how many players play on a baseball team at any given time. So here, order matters. So this is not a combination, but a permutation. I have 12 people to pick from, and I'm picking 9 because that's how many people start, and order does matter. So here I'm going to start with 12, go to math, probability, go down to NPR, and select 9 of those 12. Take a look at this, 798333600. There are 79,833,600 different batting lineups that a coach has to pick from in order to, if he has 12 members on a team. Okay, so that kind of question is something we're going to see on our homework, along with this this question. Take a look at this one. Is this a permutation or a combination first? Lockers at Homestead have 50 different numbers. Each combination, they call it a combination, has 3 numbers. But if each combination is made up of 3 different numbers, how many combinations are possible? This is a misleading word here because a combination, order doesn't matter. But we know that when we put our numbers in our locker to open it up, order does matter. The locker is actually a permutation. We shouldn't call it a locker combo. We should call it a locker permi. Okay? I'm picking from 50 different numbers, and I'm picking 3 of them. Okay? So to find out how many combinations, which is really permutations on one locker, you would start with 50. You would go to math, go to PRB, and pick 3 of them. You actually have 117,600 different combination choices for every locker at Homestead High School. Okay? So that is an actual permutation and not a combination. One final slide here, calculating the number of outcomes in which exactly 2 of 5 televisions are selected. So suppose that you have 2 different groups. You have 6 defective TVs, you have 94 non-defective TVs, and you choose 2 of the defective TVs, so you're having a combination because order doesn't matter here. You're having a combination where you're picking 2 of the 6 defective TVs, and then you're going to pick 3 of the 94 non-defective TVs. And you want to find out how many different arrangements or groups are possible. It's a combination because order doesn't matter, but then you would multiply those numbers together like we have in the counting principle. Okay, we would just take the number of choices that we have here times the number of choices that we have here. That is what assignment number 8 is about, and that is what our homework is about on Math Excel. And so we can complete that Math Excel homework assignment and be ready for our Unit 4 test. Good luck on that, everybody. We'll go over that assignment next time that we get together.